Hello, everyone. I'm Oluwashaya Kikumi, and I welcome you to this data engineering project on Amdari, which is titled Wikipedia Data Scraping, Efficient Extraction and Database Integration. Right. So what are the project's learning opportunities in this project? They include the implementation of a web scraping system using Python libraries like Beautiful Soup and Request, right? So we'll also learn how to set up and configure different database management systems using Docker. We'll get to understand the HTML structure of a given web page, particularly the Wikipedia page you'll be scraping. And we'll see how to extract the relevant information we need from that page, right? So we'll implement code to efficiently load the scraped data into various databases. And we'll explore some techniques for managing database connections and transactions from within our Python code, right? So the skills we'll get to develop in this project are web scraping skills, and we'll develop our Python programming skills as well, database management skills. We'll get to see some SQL in action, basically to load our given data into the database. That's our script data, right? Then, of course, we'll get to develop our knowledge of different database systems, right? So we'll get to work with MySQL, we'll get to work with Postgres, and also SQL Server. So let's take a look at the executive summary. The core of the Wikipedia Database Initiative is centered on extracting information from Wikipedia with a particular emphasis on the list of largest universities. This project is designed to streamline the process of collecting and integrating this university-related data into different databases. So the primary goal is to automate the retrieval and storage of information related to universities, with an initial focus on compatibility with diverse database platforms such as MySQL, Postgres, and SQL Server. Although this project can be extended to other databases in future. Right. So this approach basically ensures a systematic and efficient means of incorporating valuable university data or any data at all on the web that can be scraped from web pages into different database systems. So now let's take a look at the business problem statements. In the dynamic field of educational data management, the lack of an automated and adaptable solution for obtaining thorough university information poses a substantial challenge. Now, the manual collection and updating of data from Wikipedia or from any other web page are not only time-consuming, but also prone to errors, lacking scalability. There is a growing demand for a more efficient process to systematically gather university data from Wikipedia or other web pages and seamlessly integrate it into different databases, right? So recognizing this need has become increasingly crucial in addressing the shortcomings of the current manual methods, right? So now let's jump to the objectives we hope to achieve by the end of this project. So we want to be able to implement web scraping, that basically to develop code that can help us pull data from the web, from web pages basically, and extract what we need from those web pages, right? So this step will first involve taking a look at the web page or the website and just scanning through to see how we can, detect the information we need, or basically to see where the information we need is located within the web page, and also study the structure of the web page using the browser developer tools. So it could be Google Chrome, it could be Firefox or Microsoft Edge, right? So using the developer tool, we can locate the structure of the page, that's the HTML document object model structure of the page, and just see how we can extract what we need, right? Then we'll be doing some database setup and configuration using Docker containers, right? So as you get to find out, it's very, very easy to create a MySQL database, for example, or Postgres or SQL Server, or even MongoDB and other kinds of database or data storage systems, right? So it's as easy as just specifying a configuration and running a single command, right? So, and of course, making use of Docker, you have a very efficient setup, and you can use it to, basically develop your data pipeline, right? So we'll be taking a look at that. We'll also look at some database schema design, right? So we'll basically look at a simple schema that can help us to efficiently store the data we'll be scraping from Wikipedia. we'll, of course, integrate our web scraping code with the database, right? So eventually we need to load our data into the database, and we'll get to see how that works, right? So another objective is to, develop our SQL query in such a way that if we try to load the same data into the database, then we'll still have, the same result, right? So we don't want a query that fails when we run it multiple times, right? And of course, from the schema we design, right? We design it in such a way that existing rows can be updated if those rows have different values from what you already have stored in the database, right? So those kind of queries are called merge queries or upserts. So those kind of queries are called merge queries or upserts, right? And we'll get to see how we can do that using the different database systems, which include MySQL, Postgres, and SQL Server. And of course, cost efficiency. Our system, what we'll be setting up, requires the use of Docker containers, right? So there's really no cost attached to this setup other than to have Docker desktop installed, right? So in order to demonstrate how to scrape data from a web page and load it into these different databases, we do not need to incur any cost, basically, right? But the basic idea is once you are able to work on this project and you know how to scrape data from a web page and load it into a database running in a Docker container, then you'll definitely be able to load data into any other database that may be running in the cloud, maybe on AWS, GCP, or Azure, right? So regardless of where the database is set up, the techniques you learn in this project will help you to interact with those databases, right? So now let's take a look at what our pipeline looks like. So it's a very basic pipeline. We are going to have a Python environment which will run on our system, right? And within that Python environment, we'll get to write our code that pulls the HTML data from Wikipedia. Then we'll use Beautiful Soup to basically navigate that HTML content that we pulled, that we pulled from Wikipedia using the request library, right? Then once we have the data, we'll try to do some cleaning on the data, right? To just make sure that it's in a suitable format to be loaded into a database, right? So most of the time in the real world, you would have data that is not clean, right? So we'll just take a look at some basic cleaning techniques on the data we'll scrape from Wikipedia. We'll then go ahead to load the data into MySQL first using a Docker container. After that, we'll look at how to do the same thing for a Postgres database and also for SQL Server database, right? And this can be extended to other databases as mentioned before, right? So you see a common pattern in how these things can be done, right? In how to load data into any destination database, right? So it's a very basic pipeline. We'll get to set up. We'll be using VS Code basically. So we'll get to see how we can get a Jupyter Notebook extension within VS Code that allows us to work with Jupyter Notebooks in VS Code. And we'll also see how to get other extensions that serve as database clients, right? So they allow us to connect to different databases. And those extensions take advantage of the VS Code UI such that we can now we have a way to, or we have some spaces to write SQL queries and see the results of the queries, right? So very typical, or very similar to what you have with pgadmin for Postgres or MySQL Workbench or all these other database clients like dbeaver or Beekeeper Studio and so on, right? So this is what our pipeline looks like. And of course, we've mentioned some of the tech stack in the previous slides. So we'll be taking a look at how to load data into MySQL, Postgres, and SQL Server. We'll be using Python as our main programming language to scrape the data and also to load the data into these different databases, right? And to set up the databases, we'll be utilizing Docker containers, right? So, and the project scope basically involves understanding the project overview, which we have done in this video. And we've also taken a look at the architecture, right? So we'll also look at a systematic approach to extracting relevant university information from a Wikipedia page, right? We utilize Docker containers to set up the different database systems that we'll be loading data into. And we'll see how to load data into these different databases from within our Python environments using libraries like SQL Alchemy, PyODBC, CycleG2, and so on. Right, so that's going to be it for this video. In the next video, we are going to start pulling data from. So in the next video, we'll jump right into pulling data from Wikipedia using Python, right? So don't go anywhere. See you in the next video.